Hi guys, welcome back. So as you know, I attempted to do this video yesterday, but I just couldn't get anything to work. I think that's just such a typical Monday thing to have happen. All right, so we're going to go through what long division is. I'm going to go through a simple, quick example using just some basic numerals, and then we'll jump into long division of polynomials. Let's do a simple one. Let's start off with something like 8, and what would be another good number? Let's just pick a couple random, 6, 4, 2, 8, 4, bunch of random numbers. Okay, so the first thing that we do with long division is we say, okay, so how many times does 8 fit into 6? 8 doesn't fit into 6, so we'll go to the next digit. 8 fits into 64 8 times. And so what we've done first is we've gone ahead and we've divided. Next, we're going to multiply what we've just found here, this division factor. So we're going to go 8 times by 8, and that's going to be 64. So then we multiply. Next, I'm going to subtract the two values. So 64 minus 64 is going to be 0. So we're subtracting. And then the last thing I'm going to do is I'm going to add the next digit down. Okay, so we repeat the process now. So 8 fits into 2, 0 times. So I've done my division. 8 times 0 is 0. So I've done my multiplication. 2 take away 0 is 2. So I've done my subtraction. And then I bring down the next digit. So that's my addition. Okay, then we keep going. 8 fits into 28. Well, 8 fits into 32 4 times. It fits into 28 3 times. 8 times by 3 is 24. 28 subtract 24 is going to be 4. And then I'm going to add the next digit down. All right, so keep going. So 8 fits into 44. Well, I know it fits into 40 5 times. 8 times 5 is 40. Subtract, I get 4. Bring down the next digit. Okay, 8 fits into 46. Again, we know this is 5 times. 8 times 5 is 40. Subtract, I'm going to get 6, and then I'm going to bring down this last digit. By the way, you don't have to do all these arrows when you do this. I'm just using these arrows to illustrate a point. Okay, and then 8 fits into 64 8 times, and then to finish it off, 8 times 8 makes 64, and then the difference is 0. And we should always have a difference of 0 at the end. Now let's say we didn't have a difference of 0. I'm just going to make up this value here. Let's say we had a difference of 1. Then what we would do is we would write remainder 1 at the end. So that's what you guys would have done in primary school, doing long division. So we're going to sort of follow this process, and I'm going to use these symbols to sort of help me with this process. So we're going to divide, then we're going to multiply, then we're going to subtract, then we're going to add the next digit. Okay, so let's have a go at this first question here. I'm just going to fix this screen up. All right, so we've got to remember that we have to repeat this process. So we're going to divide, then multiply, then subtract, then add. This is kind of like the reverse order of operations, if you will, too. Okay, so what we're going to do, we're just going to look at the variable now. We're going to ignore the plus 1 for the minute. So focusing on this x. X fits into x cubed, x squared times. Okay, so I'm just going to show you. So if I did x cubed divided by x, that's going to give me x squared. So I'm going to use that principle, and a mower's going past, don't know if you can hear that, to help me fit x into each of these as well. So now what we're going to do, we've done our division, now we're going to use our times thing. And this is where it gets a little tricky, because we're going to times this whole thing now by this top value and not just the x. So the x is only used for the division part. Okay, so x plus 1 times by x squared is going to give me x cubed, because x times x squared is x cubed plus 1x squared. Okay, so I've done my multiply. Now I'm going to do my subtract. 10x squared minus x squared is going to make 9x squared. And then I might not bring down my next digit just yet. I might just leave it for the minute, and I'll bring it down the next time. Okay, so now we're continuing to work from here. So x fits into 9x squared, 9x times, because 9x squared divided by x is equal to 9x. Now I'm going to multiply x plus 1 by 9x. So x times 9x is going to make 9x squared. 1 times 9x is going to make plus 9x. Okay, so now I'm going to subtract. So 9x squared take away 9x squared is going to be 0x squared, so those terms are going to cancel each other out. And 27x minus 9x is going to give me 18x. And again, I'm not going to bring this one down just yet. So that was my subtraction. All right, so x plus 1, x fits into 18x 18 times. I'm going to now, so that's my divide done. I'm going to now multiply. So 18x plus 18. And then I'm going to subtract 18x, take 18x is 0, so they cancel each other out. And 18 subtract 18 is going to be 0. So this is now being factorized out using long division. So I could write this polynomial, x cubed plus 10x plus 27x plus 18, as x plus 1 times by x squared plus 9x plus 8. Now I could continue to factor this, and this is going to be a lot easier to factor now because it's a quadratic. So if I find factors of c that are going to add to b, I know that's going to be 8 and 1. So I could factorize this as x plus 1, x plus 1, x plus 8, because this x plus 1 has just come from here, and then this has come from factorizing a quadratic. So to rewrite that again, in the simplest form, I'm going to end up with x plus 1 squared times by x plus 8. All right, let's give another one of these questions a go. So this is a similar question, it's just been worded a little bit differently. So factorize x cubed plus 10x squared plus 25 using long division, assuming x plus 5 is a factor. So if x plus 5 is a factor, that means that this function here will be divisible by x plus 5. So what we can do, so since we're dividing by x plus 5, that's going to go on the outside, and then I'm just going to pop this information here underneath this division symbol. Okay, so again, now with this one, we're going to divide, then times, then, then we're going to subtract, and we don't really do this add step so much. It's just sort of there if we do need to bring those down. But I think it's easier just to leave them up the top when we're dealing with polynomials, just because it will get a little bit complicated otherwise. Okay, so again, we're just going to start off, when we do our division, we're just looking at these x values. So x fits into x cubed, x squared number of times. Then we're going to go x plus 5 times x squared, and that's going to give me x cubed plus 5x squared. Next, we're going to subtract, so we end up with 5x squared. I'm not going to bring that one down just yet. Okay, so now working from here, x fits into 5x squared, 5x times. X plus 5 times by 5x is going to be 5x squared plus 25x. Oh, sorry, this was supposed to be 25x. I was wondering why that was a bit different. So then I've done my multiplication. And then lastly, I'm going to subtract. So 5x squared minus 5x squared is going to be 0. 25x minus 25x is also going to be 0. So when I factorize this, this is going to become x plus 5 x squared plus 5x. And to fully factorize this, I could factorize out an x, so I have x plus 5, and then that would leave me with x plus 5, so that becomes x plus 5 squared. All right, one more example. All right, so just another way of wording this in a slightly different sense. Find the quotient and remainder of f of x divided by g of x when f of x is equal to this function and g of x is equal to that function there. So in other words, all I'm doing is I'm dividing this by x plus 2, and I should have some sort of quotient here, and then whatever the remainder is at the end if we do have a remainder. So again, we are going to do division, and then multiplication, then subtraction, and then we're going to add if we need to add. Okay, so let's go through. Again, we're just going to do the division step with x, and then we'll do the multiplication step with x plus 2. X fits into x cubed, x squared times. X squared times x plus 2 makes x cubed plus 2x squared. So check, check. Then we're going to subtract, and we end up with 12x squared. All right, next we're going to go x fits into 12x squared, 12x times. X plus 2 times 12x is going to make 12x squared plus 24x. So tick, tick, and then now we've got to subtract. So that's going to end up 65x minus 24x is going to be 41x. All right, so done that subtraction step now. X fits into 41x 41 times. 41 times x plus 2 is going to make 41x plus 82. Okay, next we're going to subtract. Sorry, I should tick these off. So next we're going to subtract, and we're left with, 100 minus 82 is going to be 18. Now, x does not fit into 18, so we're going to write this as a remainder 18. Okay, so when I divide those functions, the quotient of those of that division is going to be x squared plus 12x plus 41. I don't think this is going to be nicely factorized. I think 41 is actually a prime number, so there's not going to be any factors of 41 that are going to add to 12. And then the remainder is going to be equal to 18. And when we write the remainder, so when you're in primary school and you had a remainder, say if it was like a remainder of 1 and you had divided through by 8 or whatever, then you would write that as 1 over 8. So to write this remainder, all we're going to write it as is 18 over x plus 2, because that was my original divisor, and I haven't been able to divide 18 through by x plus 2. So that's long division and some long division of polynomials. This one's kind of a tricky one, but I think the more that you practice it, the easier it gets. And especially with polynomials, I think it's easier to solve or to factorize polynomial equations using this method. But there are other ways to do this. Alrighty guys, I will see you in the next video. Have a wonderful day. Talk soon.